All right, guys, it's time for lesson 6.2, part 2. Because if I would have put them together, we would have had a video that was like 40 minutes long, and that's too much. Okay, so we're still on properties of exponents, but we're going to talk a lot about scientific notation today. This is a portion of what was supposed to be covered within 7th and 8th grade math combination, and I think that this is something that we need to touch base with. I think you may have just kind of breezed over. So let's talk. A number is written in scientific notation when it's expressed as the product of a factor and a power of 10. So this means, factors means numbers that you multiply, right? So you have some number being multiplied by a power of 10, meaning the base is a 10. The factor must be at least 1 and less than 10. So this, for example, this is scientific notation. It's scientific notation because this factor is at least 1, right? Because 5 is greater than 1, but it's also less than 10. So this number has to fit that requirement, and it's being multiplied by a base that's a power of 10. The base of a power of 10. So it doesn't matter that this exponent is negative right here. I need to be multiplying this by a base of 10 with an exponent. So if I ask you to write it in scientific notation, you can kind of throw that negative exponent reciprocal business out the window for a little while. Okay, take a look at this first few examples here. I ask you to tell me whether this is written in scientific notation or not. So all we're going to look at is the first factor. Is this number 1 or more but less than 10? Yes. And it's being multiplied something with a base of 10, so this would be a yes. All right, when you look at B, is 9/10 1 or more? No, it's too low. I see that I'm multiplying it by a power of 10, but it's not okay if this one right here is less than 1. So what we're going to do is we're going to fix it. So this would be a no. And in order to fix this, if I just move my decimal point that way and made this a 9, it would work, wouldn't it? So if I took 9, and I'm going to say 9.0, and I can't just take this times 10 to the 8th, or I'd be changing the value. But what could I multiply 9 by, 10 to what power, to get it back to that? So if I have my decimal point here, if I wanted to make it 9/10, I'd have to move it one place to the left, correct? So you can multiply this by 10 to the negative first power, because that negative first power tells me move the decimal one place to the left. So if I multiply 9 by 10 to the negative first power, then I get this 9/10, and then I'm going to multiply that by the 10 to the 8th still, because that didn't go away. We're almost done. I just want it to make sense. I don't want to make a rule of you add 1 or you subtract 1. I want you to see why you're doing what you're doing. So this first part right here was how I changed this 9/10 into a number that's 1 or more but less than 10. Now from here, I'm going to use my laws of exponents to simplify this, because I'm only supposed to be multiplying by 1 power of 10. So I'm going to take this 9.0, and remember, when you have the same base, you bring over the base and you add the exponent. So negative 1 plus 8 is 7. So this is another way to write that. This is in scientific notation. So that one would be a yes. All right, look at the next one. I have 11.8 times 10 to the negative 4th power. Okay, this one's too big, right? If I move the decimal point one place over, then I'd have a factor that was okay. What power of 10 would I have to multiply 1.18 by to make it 11.8? Well, I need to move this decimal one place to the right, so that's a positive exponent move. So if you take 1 and 1800ths and multiply it by 10 to the first power, that would make it the 11.8 that you start with, right? So now just multiply it by that original power of 10, and then we'll simplify. So 1.18, or 1 and 1800ths, same base, bring over the base and add the exponents. So 1 plus negative 4 is negative 3. Now we have a yes. So originally this is a no, but we can change it to make it a yes. Okay. We're going to learn how to multiply and divide numbers in scientific notation, and our laws of exponents are going to help us. That's why this is tied into that section. I just thought it was a little too much to put all together. Okay, so if you see 3 times 10 to the negative 5th, this is scientific notation, and so is this. The associative property of multiplication allows us to multiply numbers in any order. So I can go ahead and multiply the 3 and the 5. That gives me this 15. And then I see, ooh, I have the same base. I remember that when I multiply the same base, I can just bring over the base and add the exponents. So that's how you can get from here to here. So multiply the numbers together, multiply the powers together. Now when you first land on this step, we're not done because this isn't scientific notation. 15 is too large. It needs to be 1.5. That would give me a factor that was 1 or more but less than 10. In order to make this 1.5 turn back into 15 so I don't change the value, I would need to move the decimal point one place to the right. So doing this allows me to get that same value of 15, and then I'm going to multiply that by the original power of 10. So from this point I would bring down my 1.5. I am multiplying the same base, so I bring over the base and add the exponents up. So the moral of the story is multiply the numbers together, multiply the powers together, and make sure that your factor is 1 or more but less than 10. So let's try a few of these. All right, I see 2.5 times 10 to the 8th times 2 times 10 to the 3rd. So I'm going to multiply these numbers together. 2.5 times 2, that gives me 5. And then here's my same base, I'll bring it over, and 8 plus 3 is 11. So I have a power of 10, and is my factor 1 or more but less than 10? It sure is, so this one is done. I love when that happens. This one probably won't be the same thing. That would be too easy. I forgot my easy button at school, so I have to make things difficult. All right, I'm going to multiply the numbers together here. So 5 times 6, that's 30. I think I'm going to make this one an X. It might be difficult to tell if I make that dot. All right, bring over the base, and then a negative 4 plus a negative 9 is negative 13. Here's my power of 10. 30 is more than 10, though. This has to be a number that's 1 or more but less than 10. So I could use this number if it were 3.0, right? So 3.0 times 10 to the what would give me 30? Well, I'd have to move this decimal one place to the right. So if I multiply this by 10 to the first power, then I get my 30 again. So I don't change the value. I'm going to multiply by that 10 to the negative 13. All right, this is all multiplication, so I can multiply whatever order I want. I'm going to bring down this 3.0, and then 10 to the first times 10 to the negative 13, bring over the base. 1 plus negative 13 is negative 12. Now it's in scientific notation, and we're good to go. All right, last page of these. We're going to divide numbers in scientific notation, and basically it's the same kind of scenario here. If we have 3 times 10 to the 4th divided by 5 times 10 to the 6th, you can take the 3 divided by the 5, and then you can use your quotient rules here. Same base being divided, I bring over the base and I subtract my exponents. So that's what this shows you, the quotient of powers property. I can take 3 divided by 5 and then 10 to the 4 minus 6 power. Well, 3 divided by 5 is 6/10, and 4 minus 6 is negative 2. This isn't okay because 6/10 is less than 1. So if I moved that decimal over, I could create a 6. In order to turn 6 back into 6/10, I would need to move my decimal point one place left. So that means if I multiply 6 by 10 to the negative first power, I get that number again. And then I need to bring this one over so that I'm not changing the value. This expression and this expression have the same exact value. We're not allowed to change value. So any order that I want, I'm going to bring down that 6, and then I just add my exponents and get 10 to the negative 3rd. So let's try a couple of these. All right, so we're going to take 4.4 divided by 2.2. When you do that, you get 2. And I'm going to multiply that by 10 to the, see there's a negative 3, there's a 5. I need to subtract from top down. So when you take negative 3 minus 5, you get negative 8. So this number, the factor, is 1 or more but less than 10, and it's being multiplied by a power of 10. So this one's done. Let's try our last one here before the math story time. All right, I want to take 3.9 and divide that by 15.6. When I do that, I get 25 hundredths, or 0.25, and I'm going to multiply that by 10 to the, I'm supposed to take a -4, that's on top, minus -6. -4 minus -6. That means I'm adding a +6, so I get 10 squared. We're not quite done because 25 hundredths is less than 1. If only it were 2.5 instead. We can make it 2.5, but we would need to take 2.5 times 10 to the -1st power. So this and this mean the same thing. I still need to multiply that by the 10 squared. Now, final answer. 2.5 times 10 to the, if I take a -1 plus 2, it's 1. So I can just say 2.5 times 10. Voila. All right. Story time. I have a little picture of a light bulb there for you. A 100-watt light bulb emits about 8 times 10 to the 8th photons in 8 times 10 to the -10th second. How many photons does the light bulb emit each second? Write your answer in both scientific notation and standard form. So here I'm giving you a little rate, right? And I'm kind of asking you to find the unit rate. The unit rate means one of something, right? So if you recall, to find the unit rate, you have to use division, right? If I want to know how many per 1 second, then I need to divide the photons by the seconds. So this would look like 8 times 10 to the 8th divided by 8 times 10 to the -10th. All right, so this should look familiar. That's what we just did. I'm going to take 8 divided by 8. That's 1. And then, when I'm dividing and I have the same base, I bring over the base, and I take top minus bottom as far as exponents go. 8 minus -10, or 8 plus +10, is 18. So this is actually all set. 1 is 1 or more but less than 10, and it's being multiplied by a power of 10. But in these directions, I asked you for scientific notation and standard form. So for standard form, basically you just write the factor that you start with. And if it's 10 to the 18th power, that means I'm adding 18 zeros after that. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 zeros. Let's put our commas in. And that is how many photons each second. Oops. I know. That is a lot. See if you can say that number for me tomorrow. See ya.